Hey, welcome to Models and Agents, episode 20. It's March 23rd, 2026, new week in AI. And if last week was anything to go by, buckle up. Let's get into it. Fair zero-determinant strategies break in the periodic prisoner's dilemma, unlike the classic repeated version. That's the headline that caught my attention today. A new theoretical paper shows that some of our favorite intuitions from repeated games don't survive when you add stochastic state transitions. What you need to know. Today's arXiv drop reveals that core assumptions from repeated games don't cleanly transfer to stochastic environments. Fair zero-determinant strategies and even tit-for-tat lose their guarantees in the periodic prisoner's dilemma. Several strong multi-agent and long-context reasoning papers also landed, alongside new work showing that automated prompt optimization can dramatically weaken LLM safety guardrails. Pay attention to the gap between theoretical elegance in repeated games and the messier reality of stateful multi-agent systems. Let's start with the top story. A new theoretical paper proves that fair zero-determinant strategies do not necessarily exist in the periodic prisoner's dilemma game. This is a simple stochastic game extension of the classic repeated setting. In repeated games, fair ZD strategies can unilaterally equalize payoffs between the focal player and opponents. And tit-for-tat is always a fair ZD strategy. Both properties fail to hold reliably once environmental state transitions are introduced. The authors derive the more complicated existence conditions for ZD strategies in stochastic games. They demonstrate the difference through rigorous analysis of the periodic variant. This matters because many multi-agent systems and reinforcement learning environments are better modeled as stochastic games. Practitioners relying on repeated game intuitions for cooperation mechanisms may encounter unexpected breakdowns. The work highlights why theoretical guarantees often weaken when moving from clean, repeated interactions to state-dependent ones. If you're designing multi-agent reinforcement learning systems, this paper will make you rethink where repeated game cooperation mechanisms actually apply. Now let's look at some model updates. First up is some sobering safety research. Researchers repurposed black box prompt optimization techniques using DSPy. They iteratively refined harmful prompts from harmful QA and jailbreak bench. They optimized against a continuous danger score from GPT 5.1. Results show substantial degradation of safety. Qwen 38B's average danger score jumped from 0.09 to 0.79 post-optimization. The effects were especially pronounced on open-source smaller models. This demonstrates that static safety benchmarks significantly underestimate real-world risk from adaptive adversaries. The paper frames this as constructive red teaming research that reveals limitations of fixed test sets. Next, we have a comprehensive study of LLM-based argument classification. The study evaluates GPT 5.2, Llama 4, DeepSeek, and others on args.me and UKP datasets. They tested chain of thought, prompt rephrasing, voting, and certainty-based methods. GPT 5.2 achieved the highest accuracy, 91.9% on args.me and 78.0% on UKP. Advanced prompting added between 2 and 8 percentage points. The qualitative analysis reveals shared failure modes. These include prompt instability, difficulty with implicit criticism, and complex argument structures. The work provides both strong quantitative benchmarks and actionable error analysis for argument mining tasks. Then there's GeoChallenge, a new benchmark for geometric reasoning with diagrams. It introduces 90,000 automatically generated geometry-proof problems. These require multi-step reasoning over aligned text and diagrams. Each problem comes with complexity ratings and formal annotations. The best model, GPT-5 Nano, reaches 75.89 exact match. Humans score 94.74 on the same task. Analysis identifies 3 recurring LLM failure patterns: exact match failures in multiple choice, weak visual reliance, and non-convergent overextended reasoning. Moving on to agent and tool developments, there's a fascinating hierarchical multi-agent architecture for onboard Earth observation. It coordinates vision language models, remote sensing tools, and role-specialized agents. The system operates under strict compute and bandwidth limits. An early warning agent generates fast hypotheses and selectively activates domain experts. A decision agent then consolidates evidence. The system was tested on an actual orbital edge computing platform for wildfire and flood scenarios. It significantly reduced computational overhead while preserving decision quality. This points toward practical autonomous EO constellations. Another strong paper formalizes the multi-robot context uncertain stochastic shortest path problem. They call it MR-CUS-P. The authors introduce a two-stage solution. First, SIMOP for coordinated context inference at landmarks, then LCBS, which stands for lexicographic conflict-based search for collision-free planning. It was evaluated in simulation and on 5 physical mobile robots in the SALP domain. The work directly tackles the real-world issue of robots needing to jointly gather information to infer operational context. Finally, in this section, there's A4VL, a multi-agent perception-action alliance for efficient long video reasoning. It implements a multi-round perception-action loop with multiple VLM agents. These agents perform query-specific frame sampling and clue-based video block alignment. They do collaborative cross-review scoring and iterative pruning until consensus. A4VL outperforms 18 VLMs and 11 long video methods on 5 video QA benchmarks. It also delivers significantly lower inference latency. The code is available, which is great news for anyone working with long video. Let's talk about some practical and community work. There's a controlled study on spelling correction in healthcare query answer systems. It looked at real consumer medical queries where 61.5% contain spelling errors. Query-side correction using edit distance or context-aware methods improves BM25 and TF-IDF retrieval. The gains were plus 9.2% in MRR and plus 8.3% in NDCG at 10 on MedQuad. Correcting only the corpus yields almost no gain. The paper includes a detailed error census and practical recommendations for healthcare QA pipelines. Another practical piece focuses on legal LLMs. It targets 2 failure modes in legal RAG: retrieval errors from lexical redundancy and decoding hallucinations when context is insufficient. The approach uses metadata-enriched hybrid RAG plus direct preference optimization. This trains safe refusal behavior in the models. The combination improves grounding and reliability for small, locally deployed legal models. This is especially useful where privacy constraints prohibit large cloud models. Okay, let's pop the hood on this belief revision work. Everyone talks about chain of thought, self-reflection, and multi-agent debate as if models are performing clean Bayesian updates. In practice, these iterative reasoning loops follow a surprisingly consistent multiplicative scaling law. It's governed by a belief revision exponent they call alpha. This alpha blends prior beliefs with new verification evidence. The core insight is that instruction-tuned models don't treat each revision step as fully independent. Instead, they apply a stable scaling factor when updating probabilities over candidate answers. Theory shows that alpha less than 1 is required for asymptotic stability under repeated revision. Values at or above 1 risk divergence or oscillation. Empirical measurements across GPQA Diamond, Theorem QA, MMLU Pro, ARC Challenge, and multiple model families show interesting patterns. These include GPT 5.2, Claude Sonnet 4, and Llama 3.3 to 70B. Models operate slightly above the stability boundary in single steps. But the exponent naturally decreases over successive revisions. This produces the contractive dynamics needed for long-run stability. This explains why reflection sometimes helps and sometimes causes models to chase their own tail. The architecture-specific trust ratios also vary. Some models overweight priors while others favor new evidence too aggressively. The gotcha that bites most teams is treating every co-T or debate step as equally valuable, without monitoring how the revision exponent drifts. When building agentic workflows with repeated self-correction, instrument the alpha exponent on a validation set. If it stays consistently above 1 across multiple steps, you are likely in an unstable regime. That regime benefits from stronger anchoring mechanisms or fewer revision rounds. So when should you actually reach for heavy iterative reasoning versus simpler approaches? This paper gives you the diagnostic tool to decide. Now, things to try this week. Test your current safety pipelines against adaptive prompt optimization using DSPy on a small held-out harmful set. You'll likely discover your static benchmarks are overly optimistic. Try A4VL on your long video understanding tasks if you're working with hour-scale content. The multi-agent perception action loop delivers both higher quality and lower latency than single model baselines. Experiment with query-side spelling correction in any domain-specific retrieval system, especially healthcare or legal. The retrieval gains are immediate and substantial. Explore the periodic prisoner's dilemma paper if you're designing multi-agent reinforcement learning systems. It will make you rethink where repeated game cooperation mechanisms actually apply. On the horizon, expect more theoretical work mapping ZD strategy existence conditions across broader classes of stochastic games. Look for expanded red teaming methodologies that incorporate continuous optimization rather than fixed prompt sets. Several long video and multimodal agent frameworks are likely to adopt structured perception action loops similar to A4VL in the coming months. Watch for domain-specific full-stack LLM workflows appearing in other scientific fields that require strict physical or logical consistency. Before we go, tomorrow keep an eye on follow-up work extending these stochastic game results to more complex agent training regimes. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.